Hey everybody, let's talk about 7.4, about these right triangles with little right triangles inside of them. So in general, you got this kind of situation, and just to make it a little simpler, I'm going to just label each one of these lengths. This here, apothem is A, this leg is B, this leg's C. This leg is Y, this one's Z, and then the big long hypotenuse is X. And I just want to run over real quick and maybe try to simplify the corollaries to theorem 7.3 that you saw in this section. So basically what this says is the length of the altitude to the hypotenuse, so that's CD, is the geometric mean of the lengths of the segments of the hypotenuse. So this altitude cuts the hypotenuse into two segments, and this length is the geometric mean of the lengths of these two segments. So this is one way to write it. AD over CD equals CD over DB, which if you cross multiply, that would give you what? CD squared equals AD times DB, and that would tell you that CD is the square root of AD times DB. Okay, and that's cool. It has lots of letters and stuff, but look up here and I'll just make it a little simpler. Here A is the geometric mean of Y and Z. So it's going to be like this. A equals the square root of YZ. Coolio. So corollary 1 just tells you that A is the square root of Y times Z. So what does the second corollary tell us? It says that this altitude separates the hypotenuse so that the length of each leg is the geometric mean of the length of the hypotenuse and the length of the segment of the hypotenuse adjacent to the leg. So what does that mean? That means that CA is the geometric mean of AD and AB, which up here would be B is the geometric mean of Y and X. Well, what does that look like up here? Let's see. A, B, and I'll just kind of copy the letters over, I think. B, and then AD, it was Y, and then X is the whole way. So AC is B, and so there's the B down there, and then AB is X, and then AD is Y. So if you cross multiply, you get B squared equals XY, and if you take the square root, you get B is the square root of XY. So I'm going to put that here too. B equals the square root of X times Y. And then on the flip-flop, C is going to be the square root of Z times X. So Z, or C, is going to be the square root of the hypotenuse times this adjacent leg. So X to the Z exhibit. So here we got kind of simpler expressions for how you would find this altitude, this leg, or this leg. Now I'll show you kind of simplified versions of these corollaries. Next, I'm going to show you how you can use this info to solve these kind of problems. And then I'm going to show you another way where you might not have to remember all the theorems. But I'll show you one like this first. So number 26, we want to find X and we want to find Y. X in this case is like this leg here, and the leg is the geometric mean of the big hypotenuse and the little part of the little hypotenuse segment. So that means, so my x, this is for 26, my x is the geometric mean of 1 and this whole hypotenuse, which is 1 plus 9, or 10. So x is the square root of 1 times 10. And 1 times 10 is 10. And 10 is just 2 times 5. So there's no perfect square factor that's going to come out. So x is just the square root of 10. And then y is the geometric mean of 9 and 10. So that's the square root of 9 times 10. And 9 is a perfect square, so that is going to be, the square root of 9 is 3, so that'll be 3 times the square root of 10. So that's how you can use the simplified versions of those corollaries. And I'll do 27 real quick because that one has the apothem in it. I'll solve for y here. Y is the geometric mean. So remember out here, A is the geometric mean of y and z. So the altitude here is the geometric mean of the segments it cuts the hypotenuse into. So that means in this situation, y, so number 27, y is the geometric mean of 2 and 6. So that's the square root of 2 times 6. And then let's see, can we simplify this at all? 2 times, now 6 is 2 times 3. And 2 times 2 is 4, so there's a perfect square. So this is the same as square root of 4 times 3, which is the same as the square root of 4 times the square root of 3, and the square root of 4 is 2, so y equals 2 times the square root of 3. Okay, now I'm going to show you a way to do this type of problem even if you don't remember any of the theorems. Basically what you can do is you can look at the small right triangle, the medium right triangle, and then the large right triangle, and make a little grid of all their lengths. So the small right triangle, the hypotenuse is C, the long leg is A, and the short leg is Z. In the medium right triangle, the hypotenuse is B, the long leg is Y, and the short leg is A. And then in the large right triangle, the hypotenuse is X, which you could also write that as Y plus Z if you wanted to, because they're the same thing. The long leg is B, and the short leg is C. And the way you would use this is you would fill in for all the values that you can actually find, and then you can take any little box and make proportion. So C over A equals B over Y could be one proportion that you could use. Or Y over A equals B over C would be another proportion you could use. So let's see how we would use this to do one of these problems. So on 26, my little triangle has the hypotenuse X. The long leg we don't know. And the short leg is 1. In the medium triangle, the hypotenuse is Y, the long leg is 9, and the short leg we don't know, but it's the same as this. Okay, the long leg of the tiny one is the short leg of the big one. And in the big triangle, the hypotenuse is 10, the long leg is Y, and the short leg is x. So how can I use this? Well, if you look right here, I've got a block here that gives me some useful info. And I can set up a proportion that says y over 9 equals 10 over y, cross multiply, y squared equals 9 times 10, take the square root of both sides, y equals square root of 9 is 3, so 3 square root of 10, which is what we got before. Then if you look right here, we've got 4 that line up for us. So I can do the proportion x over 1 equals 10 over x, cross multiply, x squared equals 10, square root, x equals square root of 10, which is what we got using those theorems too. So then let's take a look at how we can use this to do 27. We've got on our small triangle, the hypotenuse is unknown. We don't know what that is. The long leg is a y. The short leg is 2. In the medium triangle, the hypotenuse is x. The long leg is 6. And the short leg is y. And in the large triangle, the hypotenuse is 8. The long leg is x. And the short leg, we don't know. So how can I use this info? Well, I've got a proportion here that tells me y over 2 equals 6 over y. Cross multiply, y squared equals 2 times 6. Square root, y equals, and we figured out that this was 2 radical 3 a few minutes ago. Then I've got another chunk right here that can help me find x. X over 6 equals 8 over x. X times x is x squared. 6 times 8. I'm going to leave it as 6 times 8 right now because I need to figure out the factors when I look at the square root anyway. So x equals the square root of 6 is 2 times 3, and 8 is 2 times 2 times 2. Well, 2 times 2 is 4, and then this 2 times 2 is another 4. So what do I really have in here? I have 16 times 3, don't I? 2 times 2 is 4. There's another 4. 4 times 4 is 16. So square root of 16 is 4. The 3 stays inside. So x is 4 times the square root of 3. Y is 2 times the square root of 3. So hopefully there's a couple of methods you saw, and maybe one of them you like better than the other, and that's the one that you can use. So I hope you have a great day and a great life and a wonderful meal at some point today.